Okay, so in this video we want to do a couple of examples related to polynomial division, and this polynomial division is sometimes a little bit tricky. Okay, so for example, let's say that you have some polynomial p of x, for example, and that's equal to x cubed minus 3x squared plus 5x minus 3, and let's say that g of x is equal to x squared minus 2, and you want to divide p of x by g of x. So then x cubed minus 3x squared plus 5x minus 3, if you divide that by x squared minus 2, what you will get is x cubed divided by x squared is equal to x, so x times x squared is equal to x cubed minus 2x. So then you need to take the algebraic opposite of these, so negative, positive, and these two will cancel out, and then 5x plus 2x is equal to 7x, and then you can bring down the highest value of the highest value term in this polynomial up here. So you can bring this down, and then negative 3x squared plus 7x. Okay, and then so these three, this term, and this term, these have been taken care of. The only remaining term is this one. So now negative 3x squared divided by x squared is equal to negative 3, and negative 3 times x squared is equal to negative 3x squared, and that's a positive 6, and then you can basically positive, negative, and then these two will cancel out, and then you have 7x minus 6. And then you, of course, what is left here, of course, the division is over, but there is a negative 3 remaining here. If you bring it down, that will give you 7x minus 9. I hope that that's the right answer, x minus 3, and that's basically that. So that's going to be your remainder. So that's going to be your remainder, and then that's going to be your quotient, and that is your basically divisor and dividend, and so on and so forth. So the next example that we have here is, let's say that you want to divide x squared plus x minus 3, and you want to divide x raised to the power 4 minus 3x squared plus 4x plus 5, and you want to divide that by x squared minus x plus 1. Okay, so first, of course, you know that you have to write everything in descending order, otherwise you will get confused. And divide x raised to the power 4 divided by x squared, which is equal to x squared, so x squared times x squared is equal to x raised to the power 4 minus, I write this over here, minus x raised to the power 3, and then plus x squared, so plus x squared over here. So then you have these three terms down here, and I take the algebraic opposite of these three terms, so negative, negative, positive. These two will cancel out. Negative 3x squared, negative x squared is equal to negative 4x squared. And you also have this term over here, which is positive x cubed. So positive x cubed. So now you can And also you need to take down, basically, you need to take down this term over here. So that's plus 4x. So now x cubed divided by x squared is equal to x. So that is x cubed minus x squared plus x. And I'm just simply multiplying this by these three terms and writing them over here. So then take the algebraic opposite of these terms, which is negative, positive, negative. So these two will cancel out, and negative 4x squared, negative x squared is negative 5x squared. And 4x minus x is equal to 4x minus x is equal to 3x. 4x minus x is equal to 3x, and then you can bring down this 5 over here, so plus 5. Now negative 5x squared divided by x squared is equal to negative 5. So negative 5x squared positive 5x minus 5, and take the algebraic opposite of these terms. That's 0, that's 3x plus 5x is equal to 8x, and that's equal to, I'm sorry, 3, that's actually 2x. 2x, negative 5x plus 3x is equal to 2x, and then 5 plus 5 is equal to 10. So that's 2x plus 10. And I think that I've done something wrong in here. Number 2. No, I think I did something wrong in here. Let me see. Let's start over. Okay, so let's say that you have x raised to the power 4. Let's say that you have x raised to the power 4 minus 3x squared minus 3x squared plus 4x plus 5 divided by x squared minus x plus 1. So x raised to the power 4 divided by x raised to the power 2 is equal to x squared. So x squared, x raised to the power 4, negative x raised to the power 3, and then plus x squared. Right? So then take the algebraic opposite of these. You will get x raised to the power 4, then you have these two cancelled out, and then negative 3x squared, negative x squared is negative 4x squared, and then you have positive x cubed, okay? And then you can bring down your 4x over here, plus 4x, and then x cubed divided by x squared is equal to x, okay? So then x times x squared is equal to x cubed. X times negative x is equal to negative x squared. And that's a plus x over here. So then negative, positive, negative, these two will cancel out. And then you have negative 4x squared plus x squared, which is equal to negative 3x squared. And 4x minus x is equal to 3x. And you also have this 5 over here. You also have this 5 over here. Plus 5. So negative 3x squared divided by x squared is equal to negative 3. Negative 3 times x squared is equal to negative 3x squared, positive 3x, and negative 3 over here. Take the algebraic opposite of these, and then you will cancel these two out, and then you have positive 5, positive 3, which is equal to 8. So then your quotient is going to be x squared plus x minus 3, and your remainder is going to be equal to 8. Okay, so it's a little bit tricky. You need to actually be really careful there, otherwise you might make some mistakes somewhere. Or let's say that you have x raised to the power 4 minus 5x plus 6, and you divide that by 2 minus x squared, or minus x squared divided plus 2 actually. So let's do this division here. So x raised to the power 4 divided by negative x squared is negative x squared. So negative x squared times negative x squared is x raised to the power 4, and this is negative 2x squared. Negative 2x squared. Okay, so that's that. Then negative, positive, these two will cancel out, and you have positive 2x squared, and then you can bring down your negative 5x over here. And then 2x squared divided by negative x squared is equal to negative 2. Is equal to negative 2. Negative 2 times negative x squared is equal to positive 2x squared, which is this thing over here, 2x squared. And that's negative 4. And that's negative 4. And then you can basically take negative, these two will cancel out. So you have negative 5x minus 4, and then you see that the degree of this x over here is less than the degree of x over here, so you cannot basically continue, but you have this 6 still remaining here. So since you have to bring it down, actually in normal division you would get a 0 over here, but there is no point in writing the 0 over there. So I bring this down over here and I write it plus 6. So that's going to be negative 5x 6 minus 4 is equal to 2. So that's going to be your remainder. And this is your quotient. This is your quotient. So let me see if that's actually correct. Negative x squared negative 2, and the remainder is negative 5x plus okay, so this is negative 4 actually, right? This is negative 4. Negative 2 times positive 2 is negative 4, and take the algebraic opposite of that, that becomes a positive 4, and positive 4 plus positive 6 is equal to positive 10. Okay, so that is basically that. Now, the next question over here, you want to check whether the first polynomial is a factor of the second polynomial, dividing the second polynomial by the first one. Okay, so what you want to do is that the first polynomial is a factor of the second polynomial. So you have a polynomial over here, for example, t squared minus 3. That's basically the polynomial that you have. And then you have another polynomial here, which is 2t raised to the power 4. 2t raised to the power 4 plus 3t cubed minus 2t squared minus 2t squared minus 90 minus 12. Minus 90 minus 12. Okay, so you have these two polynomials. Let me check this again. 2t raised to the power 4 plus 3t cubed minus 2t squared minus 90 minus 12. and you want to know whether that's divisible by t squared minus 3. So now what you want to do, you want to know whether this polynomial over here is a factor of this polynomial. So if it's a factor, of course you can do that with division. If it's a factor, what that means is that when you divide this polynomial by this polynomial, you're going to get a remainder 0 and some other polynomial as the quotient. But there is some other way that you can do it as well. You can check the remainder theorem, and you can actually what you can do is that if the root of this, let's make basically a equation out of this. So t squared minus 3, if I set that to 0, then t squared is equal to positive 3. So t is equal to the square root of 3. Of course, you can say that t is equal to plus or minus square root of 3, or basically you can say that the square root of t squared is equal to the square root of 3, and the square root of t squared is going to be plus or minus t, and then the square root of 3 is of course the square root of 3. So then you can say that t is equal to plus or minus square root of 3. Okay. Now here we would get basically two roots for this equation, because this is a second degree equation. We could then check whether, for example, if I call this, for example, p of t, whether, for example, p of square root of 3 is equal to 0, or whether p of negative square root of 3 is equal to 0, and then if that's 0, that means that then this polynomial is a factor of this polynomial. That we can do, and we might actually do this for at least one of these examples, but let's first use division in order to make sure whether this is a factor of p of t or not. But just for now, I'm just going to write this as t is equal to plus or minus square root of 3. Okay. So basically now, in order to do the division, what you can do, of course, the division you already know how to do it. So you write this as 2t raised to the power 4 plus 3t raised to the power 3 minus 2t squared minus 9t minus 12, and you divide that by t squared minus 3. Okay, and then you can do this division over here. So now 2t raised to the power 4 divided by t squared is equal to 2t raised to the power 2. So 2t raised to the power 2 times t squared is equal to 2t raised to the power 4. And then you have 2t squared times negative 3 is equal to negative 6t squared. Negative 6t squared. And then you can take the algebraic opposite of these, negative positive. So then these two will cancel out, and then you'll have negative 2t squared, positive 6t squared. So 6 minus 4 is equal to 6 minus 2 is equal to 4. Sorry, is equal to 4 positive 4 t squared. Then you can bring down this term over here, 3t raised to the power 3 plus 4t squared. Next, you can divide 3t cubed by t squared, which is 3t. So 3t times t squared, so it's 3t cubed. 3t cubed. And 3t times negative 3 is negative 9t. Negative 9t. So negative 90. Okay, so then you can take the algebraic opposite of these, and then these two will cancel out. You will have 4t squared and then you can and then basically you will have you can bring down, of course you have 9t as well, and then you can bring down your negative 9t. If you bring down this negative 9t over here, negative 9t, it's kind of, sometimes it's kind of messy, you don't know what to do, but hopefully it works out through the steps. So these two will cancel out, 90 and negative 90, of course they will cancel out, and then you have what you have left is negative 12. So you have 4t squared minus 12. Now I really don't know, I mean, if there is any right way of doing these steps, but these steps actually do make sense to me, logical sense to me, and they work, so I'm just doing them. Otherwise there might be even a right way of doing it, which I'm not really aware of. So 4t squared minus 12 divided by t squared is going to be equal to plus 4, so 4t squared minus 12, and then if you take the algebraic opposite of these, they will cancel out, and then you will have 0 over here. So when you divide this polynomial over here by this polynomial over here, by this polynomial over here, the remainder is 0. And what that means is that this polynomial is actually divisible by this polynomial, or you can say that this polynomial is a multiple of, is a factor of this polynomial. So one more thing that you can do is use the factor theorem. So let's use the factor theorem here as well. Let's see what we get with the factor theorem. So with the factor theorem, we already basically calculated the zeros or the roots of the zeros of this polynomial, which is plus or minus square root of 3. So if I calculate p of, for example, positive square root of 3, let's see what we get. P of positive square root of 3. That's equal to 2 times square root of 3 raised to the power 4 plus 3 times square root of 3 raised to the power 3 minus 2 times square root of 3 squared minus 9 times square root of 3 and minus 12. That's going to give me basically square root of 3 raised to the power 2 is equal to 3, and then 3 squared is going to be equal to 9. So that's 2 times 9. And then 3 square root of 3 raised to the power 3 is equal to 3 raised to the power 3 raised to the power so you see, square root of 3 raised to the power 3 is the same thing as 3 raised to the power, basically square root of 3 is the same thing as 3 raised to the power 1 by 2. Okay, and then 3 raised to the power 1 by 2 whole raised to the power 3 is equal to 3 raised to the power 3 by 2, right? 3 raised to the power 3 by 2. So that's 3 times 3 raised to the power 3 by 2 minus 2 times square root of 3 whole squared is 3. It's just simply 3. And that is negative 9 times 3 raised to the power 1/3 minus 9 times 3 raised to the power 1/3. I'm sorry, 1/2. 9 times square root of 3 is 3 raised to the power 1/2 minus 12. Okay. And then let's see what we have here. So this 2 times 9 is equal to 18. And then 3 times 3 raised to the power 3/2 is equal to, so here basically 3 times 3 raised to the power 3/2 is the same thing as 3 raised to the power 1 times 3 raised to the power 3/2. And once you basically the bases are the same, meaning that, for example, we have something like 2 raised to the power 1 times 2 raised to the power, for example, 2. So what you do over here is that you write it as 2 raised to the power 3. So you add the exponents. So here you have to add the exponents as well. So 1 plus 3/2 is the same thing as 2/2 plus 3/2. 2/2 plus 3/2 is equal to 5/2. Right? So that's equal to 3 raised to the power 5/2. So that's 3 raised to the power 5/2. And here I have negative 2 times 3 is equal to negative 6. And then here 9 times 3 raised to the power 1/2 is the same thing as so 9 times 3 raised to the power 1/2 is the same thing as 3 squared times 3 raised to the power 1/2, which is the same thing as, so you have to add the exponents basically. So 2 plus 1/2 is equal to 2.5, which is equal to 5/2. Right? Because 2 is the same thing as 4/2. 2 is the same thing as 4/2 plus 1/2 is equal to 5/2. So that's basically 3 raised to the power 5/2. So I was over here, so negative 3 raised to the power 5/2 minus 12. So then you can cancel these two out. 3 raised to the power 5/2, 3 raised to the power 5/2. These, you can cancel these two out, and then you have 18 minus 18, and that's equal to 0. Okay, so that's basically, that means that p of square root of 3 is actually 0. That means that this polynomial is actually divisible by, I'm sorry, a factor of this polynomial. But there is one more thing that we have not I have a question right now. A question has arisen in my mind, and that is, what happens if I don't know. If it is at all possible that, now let me go for the other part of this, and then I will ask you the question that I have. Actually, it's a question that I have. It's not that I know the answer. So now I know that p of square root of 3 is equal to 0. So now what I want to do is calculate p of negative square root of 3. Let's see what that is. Okay, so the next thing that I want to check here is the second 0 of this polynomial, which is negative square root of 3, and I want to know if p of negative square root of 3 is also equal to 0. So let's see. Actually, I expect that it should be 0, but let's see what happens. And so you have basically 2 times, so you have 2 times negative square root of 3 whole raised to the power 4, and then you have plus 3 times negative square root of 3 raised to the power 3, negative 2 times negative square root of 3 raised to the power 2, and negative 9 times negative square root of 3 minus 12. Okay, and here you have basically so you have negative square root of 3 raised to the power 4. So since the power here is an even number, you're going to have a positive number here. So that's going to be equal to 2 times, and then square root of 3 raised to the power 2 is equal to 3, and 3 raised to the power 2 is equal to 9. Okay, and then you have 3 times negative square root of 3 raised to the power 3. So here your exponent is an odd number, so you're going to get a negative number, and then square root of 3 raised to the power 3 is equal to 3 raised to the power 3 by 2, meaning that square root of 3 raised to the power 3 is the same thing as 3 raised to the power 1 by 2 whole raised to the power 3, which is equal to 3 raised to the power 3 halves. So that's 3 raised to the power 3 halves. Okay, and here you have negative 2 times negative square root of 3 whole squared, which is positive 3. So negative whole squared is positive, and then negative square root of 3 squared is equal to 3. And that is 9 times, now this is positive, negative into negative is positive, and 9 times the square root of 3 is the same thing as 3 squared times 3 raised to the power 1 half. So that's equal to 3 raised to the power 2 plus 1 half, which is equal to 3 and a half. So 3 and a half is equal to 7 halves. So 3 raised to the power 7 halves. Okay, so let me see. So 2 plus 1 half would be 2 plus 1 half is equal to 2 is the same thing as 4 halves plus 1 half is equal to 5 half or 7 half. 3 raised to the power 2 times 3 raised to the power 1 half is equal to 3 raised to the power 2 plus 1 half, and 2 plus 1 half is 3 and a half. I'm sorry, no, 5 halves. So that's wrong. So 5 halves. So 9 times the square root of 3 is equal to plus 3 raised to the power 5 halves. 3 raised to the power 5 halves minus 12. Okay, so then this is equal to 18. Now 3 times, this is negative into positive is negative. 3 times 3 raised to the power 3 halves is equal to 3 raised to the power 1 times 3 raised to the power 3 halves, which is equal to 3 raised to the power 2 halves times 3 raised to the power 3 halves, which is equal to 3 raised to the power 2 halves plus 3 halves, which is equal to 3 raised to the power 5 halves. So that's 3 raised to the power 5 halves minus 6 plus 3 raised to the power 5 halves minus 12. Okay, so these two you can cancel out, and then you will have 18 minus 18, which is equal to 0. So the roots, the p of negative square root of 3 is also equal to 0. So what that means is that through basically division and also through the remainder theorem, we basically verified that t squared minus 3 is actually a factor of this polynomial p of t. And I had a question regarding this, but I'm just going to let go of the question. It's not that important. So that is that. Let's do a couple more of these, but only using basically division. So let's say that you have x squared plus 3x plus 1. X squared, let's say that you have x squared plus 3x plus 1 and you want to know if this is a factor of, for example, 3x raised to the power 4 plus 5x cubed minus 7x squared plus 2x plus 2, and I call this, for example, p of x. Okay, so 3x raised to the power 4 plus 5x cubed minus 7x squared plus 2x plus 2, and you want to divide it by this polynomial here. So 3x raised to the power 4 plus 5x cubed minus 7x squared plus 2x plus 2. You want to divide it by x squared plus 3x plus 1. And then 3x raised to the power 4 divided by x squared is 3x squared. So that is 3x raised to the power 4. And then that's 9x cubed plus 9x cubed plus 3x squared. And then if you take the algebraic opposite of these, you will get these two will cancel out. 5 minus 9 is negative 4x cubed. And here you have negative 10x squared. Okay, and then you have negative 2x, I'm sorry, positive 2x that you can bring down here as well. So now negative 4x cubed divided by x squared is negative 4x. Negative 4x into x squared is negative 4x cubed. Negative 4x cubed. And that's negative 12x squared. And negative 12x squared, negative 4x. So if you take the algebraic opposite of these, what you will get is these two will cancel out. Negative 10x squared, positive 12, so 12 minus 10 is equal to 2x squared. And 4 plus 2 is equal to 6x. And then you have a 2 over here that you can bring down. Now 2x squared divided by 2 is equal to 2. Okay. And 2 times x squared is equal to 2x squared. 2 times 3x is equal to 6x. And 2 times 1 is equal to 2. And you will get a 0 over here. So then you can say that this polynomial is a factor of this polynomial. Let's do one more of these. Let's do one more of these. Number 2, yes, no, okay. Okay, so the next division that we have is x raised to the power 5. X raised to the power 5 minus 4x cubed plus x squared plus 3x. X squared plus 3x plus 1. And you want to divide that by, for example, x cubed minus 3x, x cubed minus 3x plus 1. Okay. So now to do this division, so of course you need to start with this term over here, x cubed divided x raised to the power 5 divided by x cubed is equal to x raised to the power 2. X raised to the power 2 times x raised to the power 3 is equal to x raised to the power 5. X squared times negative 3x is equal to negative 3x cubed. And that's x squared. And then take the algebraic opposite of these terms. These will cancel out. Negative 4x cubed plus 3x cubed is equal to 3 minus 4 is equal to negative x cubed. And these two will cancel out. Then you can bring down this term over here, plus 3x. And you can, I mean, technically you can bring down this one as well, but you can do that later. Okay, so you have negative x cubed divided by x cubed is equal to negative 1. So negative 1 times x cubed is negative x cubed. Negative 1 times negative 3x is positive 3x. And negative 1 times 1 is equal to negative 1. Is equal to negative 1. Okay. So if you take the algebraic opposite of these terms, positive, negative, positive, these two will cancel out. These two will cancel out. And you have a positive 1 over here. You have a positive 1 over here, and you have a 1 over here remaining. So plus 1 is equal to 2. So the remainder is 2. That means that basically this polynomial is not a factor of this polynomial. We have another good example here. Let's do this as well. So we have, for example, this polynomial here, 3x raised to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5. If I call this, for example, p of x, I know that two of the zeros of this polynomial are square root of 5/3 and negative square root of 5/3. Okay, and I want to know basically all the other zeros of this polynomial. So at most it can have basically 4 zeros, so I know 2 zeros of the polynomial. Or you can basically do one more thing as well. You can, I mean, if you feel like it, you can derive these as well, but that's not necessary right now. So but if you were to actually do that, you would have to use the remainder theorem, meaning that now let me actually do that. Okay, so over here what you can see is that your polynomial is basically p of x is equal to 3x raised to the power 4 and so on and so forth. So now if you want to use the remainder theorem, what you can do is that well, basically the remainder theorem tells me that if you have a polynomial p of x, for example, of degree greater than or equal to 1, and now if x minus a is a factor of p of x, then a is, let me see what the remainder theorem was. I actually forgot it. Okay, it's not here. Let me find it first. Okay, so I just said the remainder theorem, but what I meant to say was the factor theorem actually. So the factor theorem, what it tells us is that if p of x is a polynomial of degree n greater than or equal to 1, and a is any real number, then x minus a, then basically number 1, there are basically two parts to it. If p of a is equal to 0, then x minus a is a factor of p of x. Okay, and number 2, the converse of this statement, meaning that if x minus a is a factor of x of p of x, number 2 is a factor of p of x, then p of a is equal to 0. Okay, so this is basically the factor theorem. So the way that you can use it here is actually pretty interesting, meaning that you can, based on this, you can actually factorize any sort of polynomial that comes your way. So what you want to do here is that you need to basically find at least one, basically one or two factors of this polynomial, and then and then you will reduce that to a second degree polynomial. And once it is in the form of a second degree polynomial, then you can use that method that we used to split the middle term and basically factorize the polynomial. So what that means is that basically in any sort of polynomial that you might have, whether it be, for example, a fourth degree polynomial, a third degree, fifth degree, and so on and so forth, this constant over here is actually the product of all of the zeros of the polynomial, provided that the coefficient here is 1. For example, over here right now you have 3 x raised to the power 4. So then if you actually do basically write this as a x raised to the power 4 plus b x raised to the power 3 plus c x raised to the power 2 plus d plus dx plus e. Okay, so this is the general form of a fourth degree polynomial, and call it, for example, p of x. You could write that as for example, let's take the roots as alpha, beta, gamma, and I don't know, theta, for example. Okay, so then you could write this as you could factorize this as x minus alpha times x minus beta times x minus gamma times x minus theta. Okay, and then if you actually multiplied all of these together, you will get the last term of this polynomial as basically the constant term of this polynomial. If you did the multiplication, you would get some term like alpha, beta, gamma, theta, or something like negative alpha, beta, gamma, theta. Okay, either the negative or positive. I'm not sure about the fourth degree polynomial, but it's going to be one of those. And I think that I'm not really sure about this, so let me actually do it. Let me actually do this to see what happens. Okay, so if you multiply these two together, you'll get x squared minus beta x minus x squared minus beta x minus alpha x plus alpha beta, and then this times the product of these two, which is going to be x squared minus theta x minus gamma x and plus gamma theta. Okay, plus gamma theta. And then you can multiply both of these together. I just want to show you how you can actually, otherwise it's just it takes a long time to do this calculation, but let's do it. So, and actually this is x squared. Okay, so now I will start with each term in this polynomial, and then multiply it by each term in this. But you could actually simplify these, meaning that you can write this as x squared minus x times alpha plus beta plus alpha beta. Okay, so you can do this times x squared minus x times theta plus gamma plus theta gamma. Okay, and now you can multiply each term of this polynomial into this polynomial. So x squared times x squared is x raised to the power 4, and this is minus theta plus gamma times x cubed, and then this is going to be minus x times alpha plus beta times theta gamma. Okay, and so that's the first three terms. Now the second three terms are going to be this term times each term over here. So that would be negative x times negative this term times x squared. So you would get negative x cubed times alpha plus beta, and then this term times this term is going to give you positive x squared times alpha plus beta times theta plus gamma, and then this term times this term is going to give you minus x times alpha plus beta times theta gamma, and then this term times these three terms is going to give you plus alpha beta x squared minus x times theta plus gamma times alpha beta, and then you have this term times this term, which is equal to plus alpha beta theta gamma. Okay, so this is your constant term that you would get. This is the constant term, and you see that in this basically in this basically expanded version of these four polynomials multiplied together, you see that x raised to the power 4 over here, the coefficient is 1. Okay, so you can use this in order to find the roots of any sort of polynomial. So since the coefficient is 1 and the constant term, meaning that in this whole situation over here, you can see that a is equal to 1, a over here is equal to 1 here, and your e is equal to alpha beta theta gamma. Okay, so your constant term over here is the product of all the zeros of the polynomial, and the coefficient of x raised to the power 4 is equal to 1. So that means that if your polynomial is written in this form, of course I don't care about the other terms, there is x cubed, x squared, and so on and so forth, but in this form, if your a is equal to 1, then you can assume that your e is actually the product of all the four zeros of the polynomial. Otherwise, you would have to basically take this and divide it by the if the coefficient here was something other than 1, you would have to take this and divide it by that coefficient in order to get things straightened out. But we don't want to go there. It's actually that would be a kind of a messy train of thought. So, but long story short, now since you see that over here, I mean, based on this situation, if I can get this polynomial, get it into such some sort of condition where the coefficient of x raised to the power 4 is equal to 1, then I could assume that the constant term would be the product of all of the zeros of the polynomial. Okay, so now that's exactly what I want to do. So the polynomial is, let's call it p of x, which is equal to 3x raised to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5. Okay, and now I need to, all I need to do in order to have that condition that the coefficient of x raised to the power 4 is 1, I need to take out this 3 from the polynomial. So basically you can write p of x is equal to 3 times x raised to the power 4. 6 divided by 3 is equal to 2 times x cubed. 2 divided by 3 would be negative 2/3 x squared. 10 divided by 3 would be negative 10/3 x, and 5 divided by 3 would be 5/3 minus 5/3. So you see, as I basically factored out this 3 from here, the constant term over here also changed, right? So that's what I meant by saying that if you had a coefficient here other than 1 for x raised to the power 4, then you would have to divide by that coefficient. That's what I meant by that, but it was not possible for me to explain what I meant, and I actually didn't really know what I was saying. So so that's basically now your polynomial in the form that you can assume that this constant term negative 5/3 is actually the product of all the zeros of your polynomial, being, for example, let's call them alpha, beta, theta, and gamma. Okay, so now you can, there is all kinds of possibilities here. For example, you could go for I don't know, and just to keep things, I mean, you could go, for example, you could probably go for example 5 times 1/3, or basically, I don't know. There is all kinds of possibilities here, and I'm not really sure how to get this number here. It's a little bit messy. Okay, but then at the end of the day, you wanna get your numbers in some way. I'm not going to go there actually, really. So all I know for now is that the product of all the zeros of this polynomial are negative 5/3, and you usually don't actually get to solve these kinds of problems, and these kinds of problems are usually given to some algebra system or some computer to solve, but you need to know the story behind that, and you need to actually know basically actually we did solve one of these problems, and that was also a little bit messy. You had to deal with a whole bunch of numbers and possibilities, which is actually not an easy thing to do. But again, you need to know what's going on behind the scenes, and then you can give your number to some algebra system to do that part of the work for you. So now let's assume that, based on what has been given to me in the problem, let's assume that one of these zeros is square root of 5/3, and the other root is negative square root of 5/3. And I can check whether that's actually the case. I can set up two factors using these zeros over here. So a factor for this zero would be x minus square root of 5/3, and another factor using this one over here would be x plus square root of 5/3. Okay, so these would be the two factors made from these two zeros. Okay, so now if you divide this polynomial by either of these two polynomials, you should get a zero remainder, or you could use the remainder theorem in order to check that. So now if I calculate, for example, p of one of these zeros, for example, square root of 5/3, what I would get is basically, I don't know, let's just try one of them, for example, 3 times square root of 5/3 whole raised to the power 4 plus 6 times square root of 5/3 raised to the power 3 minus 2, let me write this down here, minus 2 times square root of 5/3 raised to the power 2 minus 10 times square root of 5/3 minus 5. Okay, and then you can simplify this by, for example, square root of 5/3 raised to the power 2 would be 5/3, and raised to the power another 2 would be 25/9. So that's 3 times 25/9. Now square root of 5/3 over here raised to the power 3 is equal to, so square root of 5/3 raised to the power 3 is the same thing as 5/3 raised to the power 1/2 all raised to the power 3, which is equal to 5/3 raised to the power 3/2. So then you can come over here and write this as 6 times 5/3 raised to the power 3/2. Excuse me. And then you can, and then the next term over there is negative 2 times square root of 5/3 squared is equal to 5/3. So 2 times 5/3 minus 10 times square root of 5/3 minus 5. Okay, and then that's the same thing as now somehow you need to get rid of these things over here. So here you have 6 times, so here you have, what you can do, actually you need to write this as square root of 5/3 so let me find some way to simplify it. Okay, so now in order to calculate this thing, this is one of those little, these kinds of things are basically one of those interesting things in mathematics that you somehow get to do. And I used to enjoy this kind of thing when I was in college. So in order, you can see that here you have 5/3, 5/3, 5/3, and 25/9 is actually nothing but 5/3 raised to some power. So So what you can do here, you can write this as, so 25/9, you can write it as 5 raised to the power 2 over 3 raised to the power 2, so that means that 5/3 whole raised to the power 2. Okay, so that is the same thing as so that's the same thing as 3 times 5/3 whole raised to the power 2 times 6 times, what do I have? I think we have made a mistake over here. This is a plus, actually. This is a plus. Okay, so plus 6 times 5/3 raised to the power 3/2. And then here you have negative 2 times 5/3. And then here you have negative 10 times 5/3 raised to the power 1/2, negative 5. And I think there is something wrong here, but I hope that we get, and we kind of know that the answer is 0 here. So, so in order to be able to do this kind of calculation here, basically the power is 2. Here is the power is 3/2. So you kind of have to have the same power for everything, so that you can add them together. And the way that you can do it is 5/3 raised to the power, you need to find some common exponent here. You need to find some sort of common exponent here. But let me actually find this, because I'll have to think about this for a while. I'll find the answer and I'll come back. Okay, so basically what I actually tried to basically to simplify this this expression over here, but as it turns out, it's a lot of trouble to actually do that. So I'm not going to bother about that, but I actually did calculate this using a calculator, and you see that the whole expression is giving me 0. That means that this thing is actually equal to 0. Okay, so this is equal to 0. So now what that means is that basically we have this polynomial over here, p of x is equal to 3x raised to the power 4, and so on and so forth. So this is the polynomial that I have, and basically one of the factors is going to be this factor, and one of the factors is going to be this factor. And so you can actually write it as, p of x as, let me erase all of this whole thing over here, and I don't really need this thing as well. So the way that basically you can write p of x as you can write it as x minus square root of 5/3 times x plus the square root of 5/3 5 plus square root of 5/3, and times some polynomial, for example g of x, for some polynomial g of x. Okay, and then I'm going to erase all of this as well. So I know that 2 of the factors are square root of 5/3 and negative square root of 5/3. These are two zeros of this polynomial. So now what I need to do here is basically find this polynomial g of x. And the way that I can find it is that I can write g of x is equal to p of x divided by these two polynomials. So x minus square root of 5/3 times x plus the square root of 5/3. Okay. So now basically this is this thing in the denominator is x minus a into x plus a, which you can write it as x squared minus a squared, or you can say a minus b times a plus b, which is equal to a squared minus b squared. This is basically the same thing. So then basically x minus square root of 5/3 times x plus the square root of 5/3 is going to be equal to x squared, is going to be equal to p of x over x squared minus square root of 5/3 whole squared, which is basically simply 5/3. Now what you need to do is now divide p of x by this polynomial. So let's do this. So basically you have 3x raised to the power 4 plus 6x cubed minus 2x squared minus 10x minus 5, and you want to divide that by x squared minus 5/3. Okay, and the way that you can do that, so basically 3x raised to the power 4 divided by x squared is equal to 3x raised to the power 2, 3x raised to the power 2, so 3x raised to the power 2 times x squared is equal to 3x raised to the power 4, and this is going to give me 3 and 3 will cancel out, so then I have negative 5x squared, negative 5x squared. And if I take the algebraic opposite of that, negative positive, these two will cancel out. This will give me 5 minus 2, which is equal to 3x squared. And then I can bring down this as well, so 6x cubed plus 3x squared. Now 6x cubed divided by x squared is equal to 6x. 6x times x squared equals to 6x cubed. So that is 6x cubed minus, so 6 and 3. So here you have 6 divided by 3 is equal to 2. 2 times 5 is equal to 10. 10x. So that's negative. Actually I can write this as, so negative into positive is negative, and then I have 6 divided by 3, 2 times 5 is equal to 10x. So negative, positive, and then these two will cancel out, and then you have 3, you have 3x squared, 3x squared plus 10x plus 10x, and then you can bring down the negative 10x here as well. This one you can bring it down, and these will simply cancel out, and negative 5 you can bring it down. So you have 3x squared minus 5. Now if you multiply this by a factor of 3, so plus 3, that's 3x squared and negative -5, and then you will have a 0 there. Okay, so then this is going to be equal to 3x squared plus 6x plus 3, and I'm going to erase all of this thing over here. Okay, so now I know that my basically p of x is, I know that p of x is equal to basically these two factors times g of x, and g of x is this polynomial. So that's x minus square root of 5/3 times x plus square root of 5/3 and times this polynomial, which is 3x squared plus 6x plus 3. Okay, so then I have basically all I need to do is factorize this polynomial. So about this polynomial, what you can do is you can simply take a 3 out. So 3x squared plus 6x plus 3, you can write it as 3 times x squared plus 2x plus 1. Okay, 3x squared plus 6x plus 3. And then you're looking for two numbers a and b such that a times b is equal to 1 and a plus b is equal to 2. So let's say it's 1 and 1. 1 times 1 is equal to 1, 1 plus 1 is equal to 2. So if I write this as, I think this is x plus 1 whole squared. So if I write this as x plus x squared plus x plus 1, okay, so that's going to be x times x plus 1 plus 1 times x plus 1, and that's x plus 1 times x plus 1. So what that means is that you can write your p of x as x minus square root of 5/3 x plus square root of 5/3 times x plus 1 whole squared. So that means that the two other zeros of the polynomial are -1 and -1 coincident. So if you set this to 0, x plus 1 is equal to x plus 1 is equal to 0, that will give you x is equal to -1. So your zeros are negative square root of 5/3, positive square root of 5/3, and -1. Of course, -1 you have it twice as but coincident. And if you want to, I don't know, if you want to see a graphical representation of the graph of this polynomial, you can go to you can always go to desmos.com and do a graph of the function. It's actually a very good idea. Always you get a lot of familiarity with the way that these different things are represented graphically. Okay, so that's basically that. We have a couple more exercises here. We will go through them as well. We will do a couple of them, but that we will have to do in the next video. See you in the next video.